Hi, in this video I want to talk about the difference between radius of convergence and interval of convergence. When you are in your homework or exam in a calculus class, how do you handle a radius of convergence question, and how different is it to handle a interval of convergence question? Well, both questions involve power series. And the power series could be centered at 0, in which case we call it a Maclaurin series, or it could be centered around some other number a, which is the general form of the Taylor series. In this video, I'll just talk about centered around 0 to make it simple. To find the radius of convergence, the most straightforward way is usually to use the ratio test or a root test. In carrying out a ratio test or root test, what you do is you either take a ratio, absolute value, or a root, absolute value, and you take the limit as n goes to infinity. First of all, the inside of the absolute value will have expressions in x. And the rules for both the ratio and the root test are that if the limit is less than 1, then the series converges. If the limit is greater than 1, then the series diverges. If the limit is equal to 1 right in between, then the tests are inconclusive. We're looking for convergence, right? So we want the limit to be less than 1. So what you do is you write limit of the absolute value of either ratio or root is less than 1. You work out the limit, and the limit is as n goes to infinity. So when you work out the limit, the x is still around. So you end up with an expression in absolute value of x less than 1. Solve for absolute value of x. Then you end up with absolute value of x less than some number r. That number r is your radius of convergence. So if the question asks for the radius of convergence, you're done. Now, what about interval of convergence? So let's say that you end up with absolute value of x less than r, and the number r is, let's say, 5. Then that means x is between -5 and 5. Does that mean the interval between -5 and 5 is your interval of convergence? Yes and no. Yes, it is an interval between -5 and 5, but there are 4 intervals that can claim to be between -5 and 5. You have the closed interval, where both endpoints, both the -5 and the +5, are included. That's an interval between -5 and 5. And then you have the open interval, -5 excluded, +5 excluded, only everything in between. That's also between -5 and 5. And then you have the half open, half closed type of intervals. Closed at -5, open at 5, or closed at +5 and open at -5. So you have 4 intervals that can claim to be the interval between -5 and 5. And your job is to figure out which of the 4 is the true interval of convergence. The way to do that is to plug in the endpoints into the series and work out whether or not the resulting series converges. So you plug in -5 into the series, it becomes a series without an x in it, and then you figure out if that series converges. At this point, do not use the ratio or root test. They will not help you. Use something else. Comparison test, limit comparison, integral, whatever else you use, but do not use the ratio root test, just a waste of time. Figure out if -5 plugging in the series results in a convergent series. Do it again for +5. Whichever series converges, your interval will include that number. And whichever number makes the series divergent, exclude that number. Then you end up with your interval. For example, if you plug in -5 and the series converges, closed at -5. And you plug in +5 and the series diverges, open at +5, etc. Now, You may say, wait, when I was solving the limits, I arrived at absolute value of x is less than 5. That means negative 5 less than x less than positive 5. Wouldn't that be an open interval? Isn't the open interval automatically the interval of convergence? No. The open interval is automatically part of the interval of convergence, but the actual interval convergence may be close on one or both ends. Why? Remember that the ratio and root test says if the limit is less than 1, the series converges. Great. But if the limit is equal to 1, the test is inconclusive. And that is what's happening at negative 5 and 5. At the endpoints, the ratio and root test would result in equal to 1, and it would be inconclusive. And that is why we don't know if the open interval is it yet. It's also why when it comes time to plug in x equals negative 5 and x equals 5, it's pointless to do the ratio root test, because then you just end up with equal to 1, and that's inconclusive again anyway. So that's why when you do plug in the values, go for another kind of test. Comparison, limit comparison, integral, etc. Right? Hope that helps. Any questions or comments? Put it in the comments section below. Like, share, and subscribe for more contents. And thanks for watching. Bye.